Express cos theta plus 4 sin theta in the form of r cos theta minus alpha, where r is greater than 0 and alpha is in between 0 and 90 degree. Hence, solve the equation 2 cos theta plus 8 sin theta equals to sec 70 for theta between 0 and 360 degree. Alright, so to solve this equation, first from the equation which is cos theta plus 4 sin theta, we want to form it in the form of r cos theta minus alpha. Alright, so we want to find the value for r and alpha. So first we can expand cos theta minus alpha using compound angle formula. So cos theta minus alpha is equivalent to cos theta cos alpha plus sin theta sin alpha. Alright, and then we can multiply r to both terms, and then we can compare the left hand side and the right hand side. So at the left hand side we have cos theta, also at the right hand side we also have the term which is contained cos theta. So that means this term is equivalent to cos theta, so we can equate those two terms. So cos theta is equals to r cos theta cos alpha, and then we can divide both sides by cos theta. So what is left is r cos alpha equals to 1. Okay, so this is the first equation. And then we can compare the second term, which is 4 sin theta is equivalent to r sin theta sin alpha. And then we can cancel sin theta. So what is left is r sin alpha equals to 4. So now we have these two equations. So we can use these two equations to find r and alpha. So to find r, we can use this formula. So r is equals to sec a squared plus b squared. Okay, where a is equals to 1 and b is equals to 4. Right, so we can simplify this expression. So we get r is equals to sec 17. Okay, so this value for r. So next is to find alpha. So to find alpha, we can divide the second equation with the first equation, which is the second equation is r sin alpha equals to 4 is divided by r cos alpha equals to 1. So we can simplify here, so we can cancel out r. So sine over cos is tangent. Okay, so tangent alpha is equals to 4. So we can find alpha. So alpha is equals to arctangent 4, which is equivalent to 75.96 degree. Alright, so now we have the value of r and alpha. So we can substitute into the expression r cos theta minus alpha. So r is equals to sec 17 and alpha is 75.96. Alright, so we solved the first question, and then the second question is to solve the equation 2 cos theta plus 8 sin theta equals to sec 17. Alright, so 2 cos theta plus 8 sin theta equals to sec 17. At the left hand side, if we look carefully, that is equivalent to 2 times cos theta plus 4 sin theta. And from the previous question, we know that cos theta plus 4 sin theta is equivalent to sec 17 cos theta minus 75.96 degree. Alright, so we can solve this equation. Right, so we can divide by 2 over sec 17 and we simplify. So what's left at the right hand side is half, and this is a single trigonometric equation, so we can solve the single trigonometric equation easily. Right, so first we find the basic angle alpha. So alpha is equals to arc cos 1 over 2, which is equals to 60 degree. Right, so this is the basic angle, and then we see from the single equation, okay, this is cos positive. So cos positive only occurred in first and fourth quadrant. So in the first quadrant, okay, theta minus 75.96 degree is equals to alpha, where alpha is equals to 60 degree. And then we form the general solution. So the general solution is theta minus 75.96 degree equals to 60 plus 360 times n. And then we simplify this equation, we get theta equals to 135.96 degree plus 360 times n. So this is the general solution in the first quadrant. In the fourth quadrant, okay, theta minus 75.96 degree is equals to 360 minus alpha, where alpha is equals to 60 degree. So this is equivalent to 300 degree. And then we form the general solution. So theta minus 75.96 degree is equals to 300 plus 360 times n. And then when we simplify this equation, so we have theta is equals to 375.96 plus 360 times n. Alright, so this is the general solution. So now we're going to substitute the suitable n that satisfy the range for theta. Alright, so first we substitute n equals to 0. So when n equals to 0, we get theta is equals to 135.96 degree. And in at the fourth quadrant, okay, when n equals to 0, so theta is equals to 375.96 degree. And when n is equals to negative 1, okay, theta is equals to negative 224.06. And when n equals to negative 1 in fourth quadrant, theta is equals to 15.96. Alright, so from these four value, so we need to verify using the range of theta. So theta is in between 0 and 360. So that's mean 375 is out of range. Also the same for negative 224. So that's mean the solution for this question is theta is equals to 135.96 degree. And another one is 15.96 degree. Alright, so this is the solution for the equation.